Okay, well, I am recording this lesson. This is Friday, 5/3, and we are having a beginning notes of 10-1 sequences, series, and sigma notation. I'm recording the lesson because quite a few people are prom decorating, and we're writing homework A. It is page 589, numbers 1 through 11 all. It's due on Tuesday. We're having an abbreviated lesson, and then we're going to work on that in class today. Also, I will just comment on your mid-quarter grades because we really haven't had a classroom time. I did notice that the post-test for Chapter 4, worksheet page 47 and 48, I needed from about 9 people. And so if you think you have that still, make sure that you're turning it into me. So this is 10-1 sequences, series, and sigma notation. You know, it is kind of after the fact, but if you do move on in mathematics, in pre-calculus, this is covered as well, and so it's a good little thing. I do want to get into Chapter 5 as well, some more work with trigonometry, and I debated whether to just move straight into this or into that, but I think we can get a little taste of all of this. And so just like in pre-calculus, I tell people the first section is almost harder than the next couple sections because the first section is like an overall sequences, series, and sigma notation, whereas when we get to section 2, it's probably arithmetic sequences, and section 3 will be geometric sequences. So then we're focusing on one kind of sequence problem as we look at it. So keep that in mind, you know, if you struggle a little bit to kind of find some of these sequences or and you're not sure where they come from, that might just give you a little, don't worry about it, because as we go on, it'll work out better. Also, we'll have a quest on these 3 sections. I think we do just 3 sections in this. So it's 10-1, 10-2, 10-3. And so a quest is a quiz and a test all in one. So it's a little bigger than a quiz because your quizzes are, you know, 10 to 20 points or something, and a test is 100%, you know, is what I give you. So it'll be some, you know, more than a quiz, but less than a test. And it is a quest. Yeah, how about that? You know, that is kind of cute. So, can you interpret different types of sequences and use sigma notation to represent and calculate sums of series? So the difference between these words, sequence and series. Sequence, a list of numbers, 2, 4, 6, 8, 10. Series, a sum of that same kind of list. So 2 plus 3 plus 4, or 5 plus 5 plus 6 plus 7 would be a series. Here's all of our vocabulary, sequence, term, finite sequence. We'll kind of go over some of these. A sequence is just an ordered list of numbers. Each number is called a term. A finite sequence is something like 1 plus 1 comma 3 to 1, 3, 5, 7, 9, 11, and it has a finite number of terms. An infinite sequence goes on forever, and there is, when you're listing a sequence, you're listing these numbers, there is a hidden domain, and the hidden domain is like numbering each of these. So this is the first term, the second term, the third term, the fourth term, and so there's a hidden domain of telling which term we're talking about as we look at these. So just be aware of that. And so f of 1 is a sub 1, f of 2 is a sub 2, f of 3 is a sub 3, and f of n is a sub n. And so we will be using that hidden domain and be expected to know that as well. And infinite sequences, with the same first few terms, often we can figure out what that is, but keep in mind there could be two different sequences for the same, first two or three or four terms. That's why the more terms we're given, the more likely we're kind of guessing. And we are using inductive reasoning, which is like by patterns and looking for something that we think is a relationship. We can't always be sure unless we're given an explicit formula, which gives you the nth term a sub n as a function of n. And so I'll just kind of give you some little pieces of information here. So if I have 2, 4, 6, 8, 10, and that's my infinite series. And that hidden domain is the set of natural numbers. Natural numbers are the counting numbers 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So if I was asked what is a sub 5, it's 10. It's the fifth term. So this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and then dot, 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 a sub n, dot, dot, dot. And we can go forever as we go through. And you'll see that sometimes we can give that as a little rule as well, and that's what we'll want to do is in some of those. So right now we're kind of guessing, and your job, and I'm just going to call on you. So it's 3, -1, -5, -9, 1, 2, 3, 4. Decide what the next four terms are, and then let me give everybody a moment, and then we'll see what happens. Who can tell me what they are? And what's happening? Okay, we're subtracting 4 every single time. So could you find the 50th term of this? Okay, repetitively subtracting is going to be hard just because of keeping track. Do you know how to have your calculator so you just repetitively press enter to do that? If not, take your calculator a moment and just do this. If you go 3 enter, it's like you're seeding it that number. You're giving it that number to use. So 3 enter and then -4 and then count every single time you press enter. And just this is 1, 2, 3, 4, 5, 6, 7, 8. Do that 8 times and see if you get or 7 times maybe. Yeah, 7 times. And see if you get it. And so that's a way to continue your and that is by looking at a term in a set of terms in terms of the previous one, and we'll talk about that as time goes on as well. And so, here's the next one. 1B. 18, 15, 10, 3, -6, 1, 2, 3, 4. A little different for this one. Oh, and by the way, that last one was an arithmetic sequence, which just means it had a common difference, adding and subtracting. This one's maybe a little bit different. Okay, what's this one? Say it again. -17, yeah. What's next? Okay, how'd you get it? So what does that mean? Oops, okay, so do you agree that's not as maybe straightforward, correct? And that's not arithmetic because it's not the same difference every time. We didn't subtract 3, subtract 3, subtract 3. But there are ways to get rules for these as well, and we'll kind of look at them as we go. Yep. Well, there's there's really arithmetic, geometric, and kind of other, not arithmetic or geometric. And so like on a pre-calculus test we took earlier this year, you know, the question was, here's a bunch of sequences, are they arithmetic, geometric, or neither? So those are the two that are named, because arithmetic is related to linear equations and geometric are related to exponential equations. And anything else is just a kind of a mix of things. It's kind of like even, odd, or neither, right? Because you know, when you're testing that, it's either even or it's odd, or everything else is neither. I mean, a different maybe situation. But now here's a different way of looking at things. So 1C, find the first 4 terms of the sequence given by a sub n equals n to the third plus 1. And this is where we have to use our hidden domain. What is our hidden domain? 1, 2, 3, 4, right? Do you agree? So we have to use our hidden domain. Our hidden domain is the natural numbers. 1, 2, 3, 4, 5, and that's what we kind of, I'll say it this way, like put in. So if I want the first 4 terms, a sub 1 is, and then you just have to follow, n is 1, so it's 1 to the third plus 1, or 2. A to the second is 2 to the third, oh, hang on a second, it's 2 to the third plus 1, which is 9. A sub 3 is 3 to the third plus 1, 28. A sub 4, let me just slide that. A sub 4, 4 to the third plus 1, or 65. So the sequence that we're writing the first terms of is 2, 9, 28, and 65. And so that is just, you know, kind of a taste of what's happening there. We'll do just a few more things, and then we'll work on that other stuff. And we'll save that for later. So sequences can also be defined recursively. So that last one was a rule. Oh, I didn't say it then, but do you agree if I asked for the 50th term there? Super easy, right? Because a sub 50, 50, well, easy, but, you know, big number or whatever. But easy because you have a little formula. That's an explicit formula. But recursive formulas, we have to go one right after the other. And so for a recursive formula, we just have to kind of keep finding terms and using previous terms. So when it's done recursively, the nth term is found by using the previous define the terms. So let me read this a second. Sequences can also be found recursively. Recursively defined sequences give one or more of the first few terms. So sometimes it'll give a few terms as we go, and then define the terms that follow that using the previous terms. So recursive is a recurring thing as we go. So here's number 2. Ready? So this is recursively defined sequences. If we want to find the 4th term of this, write this down. A sub 1 is 3. A sub n is 3a sub n minus 1 minus n plus 2, where n is greater than or equal to 2. Now, it looks kind of like a lot, and I will point out this. You're not only using a previous term, but you're actually using that n for the term that you're using. And so that's a unique situation. Sometimes it'll just have, like, you know, 3 times a sub n minus 1 plus 2. Sometimes it'll have a sub n minus 1 and a sub n minus 2. So that would be the previous two terms. Do you agree that you would be using as you go through? So they told us the first term, and notice they're saying n is greater than or equal to 2 because they've got 1 right there, right? So then 2 is the next thing we're going to find, and we want the fourth term. We're going to go through it term by term. So a sub 1 is 3, a sub 2 is 3 times a sub, can I just go 2 minus 1 is 1, right? A sub 1 minus the plain old number 1 plus 2. So that's 3 times the previous answer, which is a sub 1. And well, I am going to write it, especially because we don't have everybody here. So this a sub 1 term is that 3 from up there, minus 1 plus 2. I'll just leave it like that. So a sub 2 is what? 9 minus 1 plus 2? 10. So there's a sub 2. A sub 3, I'm just going to go up over here so I don't run out of room. A sub 3, and I have to follow this thing right here, is 3 times a sub n minus 1. 3 minus 1 is 2. Minus what? 3. I know. Why is it 3? So you have to be careful here. So a sub 3 is 3 times a sub 2 minus 3 plus 2. Sorry, I didn't. Because we made a mistake. Oh my goodness. Oh, I'm sorry. Darn. Okay. I made a mistake, so I'll write it in this black color. So minus n, plus, so it is back to 9. Ooh, good thing we haven't actually done this next one. So my error, I apologize. So it is n, and we do want to be careful of that. So don't make the mistake that I just made. So I'll watch my notes a little more carefully. Okay, so now a sub 2 is 9, and we have established that we are subtracting n, but then adding 2. So the n will change every time, and we do want to use n. My bad. So a sub 3 is 3 times, what's a sub 2? 9. Good thing we corrected it when we did and didn't have to go back. And then minus 3 plus 2. So a sub 3, 27 minus 3 plus 2 is what? 26. So let's see if we can find a sub 4 without making a mistake. And do you agree, by making that one little mistake, everything would be wrong, correct? But do you also agree that if you are showing your work and you get a lot of credit for following the procedure even if you make a mistake? So a sub 4 is 3 times a sub what? A sub 3 minus what? 4 plus what? 2. And so a sub 4 is 3 times a sub 3, which is 26, minus 4 plus 2. And that's what we were asked to find as we go. Okay, ready for the very last thing? Oh, yeah, the very last thing. Who in this room knows what a Fibonacci sequence is? Okay, good. That's next. And is it defined explicitly or recursively? It's defined recursively. And that's all we're going to do is write a Fibonacci sequence to start with. And then okay, Fibonacci sequence defines many patterns found in nature. This sequence is often defined recursively. Here are the first terms of it: 1, 1, 2, 3, 5, 8, 13, 21. What do you do? What what has to be defined first before you can find other terms? The first two terms. So you have to know a sub 1 is 1. You have to know a sub 2 is 1, right? And now, how do you find a sub n? Can you do that? Generally, a sub n minus whichever one, 2, plus a sub n minus 1. And what do you start with for n? 3. Why 3? Why 3? Right. 1, 2, 3. So for n greater than or equal to 3. And so let's just kind of validate for ourselves, because not everybody is super familiar with Fibonacci. So a sub 3 is a sub 3 minus 2 plus a sub 3 minus 1. So that's a sub 1 plus a sub 2. And that's 1 plus 1. And that's this 2 right there. And just a little familiarity. What are some examples of Fibonacci? Anybody know any? Oh, say it again. Flower petals. What are other things? Say it again. Leaves on stems. I was going to say acorn shells, but that's not acorn. Pine cones. Scales on a fish. And nautilus shells. Do you know a nautilus shell is, with the cavities and yeah. It kind of is, but okay. Okay, so your job now is page 589, 1 through 11 all. And it's really not due till Tuesday, but let's face it, some of you have a busy weekend. Do it now, you'll be done. I know, well,